Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Izzul Idlan bin Yaakob. My ID number is AA18250. My supervisor is TS Dr. Rokiah binti Othman. For my research methodology and pre-project, my title is the effect of water to cement ratio on the fresh and hardened mortar containing palm oil fuel ash and cockle shell as a cement replacement material. Okay, for introduction, environmental pollution caused by disposal of solid waste generated from both palm oil industry and cockle shell trade has motivated researchers to explore the potential of this waste. Okay, looking at the increasing of cockle production, it is expected the availability of cockle shell as waste would be in larger amount as well, which in turn will pose negative impact to the nearby area. For POFA, material are also known as a pozzolanic ash and are believed to enhance the strength of mortar. Okay, thus in this research, the effect of using optimal percentage of cockle shell and POFA as a partial cement replacement in water cement ratio were investigated. Okay. For problem statement, first is reduce the waste. Okay, palm oil accounted for 61.8% of Malaysian export value in 2011, and around 2 million tons of POFA, byproduct of the palm oil industry, were disposed. Okay, next according to the Malaysian Department of Fisheries, 57,000 tons of cockle were gathered along Peninsula Malaysian west coast. The cockle shell may emit an unpleasant odor if it left untreated and discarded carelessly. Because of its high uses as a food ingredient, cockle production climbed by 3.53% in 2010 compared to the 2009. Next. Okay, for the reduced carbon dioxide emission. Carbon dioxide emission, one of the cement industry byproducts, show the influence of cement on the environment. The cement industry is one of the greatest carbon dioxide emission. Global carbon dioxide emission from cement manufacturing 377 million metric ton of carbon in 2007. Okay, the amount of the carbon dioxide emitted during cement manufacture and the process of cement hydration is roughly 900 kg for every 1000 kg of cement produced. Okay, next. Okay, for my research objective, the first one is to determine the effect of water cement ratio on workability of mortar containing POFA and cockle shell. Now, the second one is to determine the effect of water cement ratio on compressive strength of mortar containing POFA and cockle shell. And the lastly is to determine the effect of water cement ratio on water absorption of mortar containing POFA and cockle shell. Okay, for my significance of research, the first one is to reduce the cost of raw material in mortar production. The second one is to make better use of the waste material generated and to limit the amount of waste that end up in landfill. And the lastly is to develop environmentally friendly, long-lasting concrete in the construction industry. Okay, for my literature review for cement, this is my literature review for cement. Okay, next. This is literature review for my sand, and then for POFA and literature review for cockle shell. Okay. Okay, so at my left slide is chemical composition of OPC and POFA, and at the right is chemical content of pulverized cockle shell. Okay, this is the particle size distribution for POFA, and then particle size distribution for cockle shell, and this is the literature review for properties. Okay, so for my gap of knowledge, the first one is most of the previous research recommend that the optimal replacement level of cement by POFA are 30 to 20%, and for Cockle Shell 20 to 10% respectively. Okay, the second one is POFA consists of hard silica oxide, which enable it to be used as a cement replacement or as a filler, while Cockle Shell contains 96 of calcium carbonate that can be converted into a calcium oxide, which can absorb carbon dioxide in the production of mortar. Okay, the last one is the particle size of the mechanical ground POFA, ranging from 7.2 to 10.1 micrometer, was lower than that of cement, whose particle size range of 10 to 20 micrometer. The average particle size for Cockle Shell was 13.56 millimeter. Okay, next. Okay, for methodology, the mixed proportion, the cube size that I will use is 50mm, and the sample is 36 cube, and containing 30% of POFA and 10% of Cockle Shell. Okay, the cement sand ratio is 1/3, and water cement ratio that I will use is 0.3, 0.35, and 0.4 and 0.45. Okay, and the grade of mortar is 25 megapascal. Okay, so this is my methodology of mixed proportion. The water cement ratio from 0.3 to 0.45, and this the cement value is 612, and the water content is 183.6 and to 275.4, and the sand is 884 kilogram per meter cube. For POFA, I will use 55.5, and the Cockle Shell is 18.5 kg per meter cube. Okay, next. Okay, for the lab test. Okay, first is flow table test. The aim is to determine the effect of water cement ratio on workability of mortar containing POFA and Cockle Shell. Okay, next. Next test is compressive strength test. Is to determine the effect of water cement ratio on compressive strength of mortar containing POFA and Cockle Shell. Okay, and the last test is water absorption. This is to determine the effect of water cement ratio on water absorption of mortar containing POFA and Cockle Shell. Okay, so this is my workflow. I will start with selection of material, and then check passing size of material. If no, I will grind or sieve the material. If yes, I will continue to the specimen preparation, and then I will go to the workability test, then water curing at 7 and 28 days, and then testing setup, which is compressive strength test and water absorption test, and then go to data collection and analyze, and lastly is do the report. Okay, this is my Gantt chart for SEM 1, FYP 1. Okay, next. This is the Gantt chart for FYP 2 at the semester 2. Okay, the expected outcome is possible to measure the effect of the water cement ratio on the workability, compressive strength, and water absorption of mortar containing POFA and Cockle Shell. The optimal water to binder ratio 0.35 in the case of cement sand ratio of 1/3 result in the highest compressive strength of cement mortar. Okay, that's all from me. Thank you.